Diagram conversion with motor circuits, multiple location control. All right, let's take a look at what this will involve. Not only are we trying to convert a diagram from a schematic to a wiring form, we are also attempting to do this in the most efficient way possible, which means the least number of conductors. So what we're going to start with here is a panel board, a push button station on the left, push button on the right, motor at the bottom, and the starter I'm going to place in the middle. And that starter, I'm only going to list the three NEMA numbers that we typically would connect to, NEMA 1, 2, and 3. Let's then start with the power circuit. Power circuit will take three conductors from the panel, and they will terminate to the top or the line terminals of the motor starter. I'm not going to draw them inside this starter here because they don't really need to terminate to these terminals at the top, and it kind of clutters the diagram. On the bottom, I'm going to do the same thing. We know that there are three conductors that would terminate to the bottom of the overload relay. Those would go through this conduit and terminate to the motor. All right, well, the easy part's out of the way. Let's take a look at the control circuit then. The control circuit, NEMA 1 connects to the first push button. And when they're equal distance away, it makes no difference which one I choose. Remember, we're trying to do this in the most efficient way possible. In this first example, there's really not much we can do to screw that up. So NEMA 1 connects to the first push button, and then out of the first push button, I have to go all the way back to the second push button, or the second normally closed. So I come all the way out of here, chase along the bottom. Oh, I'm gonna do a nice big route all the way around. There we go. So that's the second connection. Now that normally closed connects to the normally open push button. So that would be right here. So I'm gonna connect those two together. And then I also have to connect this down to NEMA 2. It doesn't matter which of the two push buttons I choose. I'm going to go from the normally open. So that would be from this same spot, right? This same spot, I'm going to have to take a wire and go all the way back to NEMA 2. There we go. All right, final step would be to take this normally open push button and connect it to NEMA 3. So there's the open terminal. I go all the way back to NEMA 3, and there we are. So what we have in this conduit then is three conductors in the top conduit, two conductors in this side conduit, three conductors going to the motor, and then three conductors going down in this direction from my main push button station. Let's take a look at another example. There's so many different orientations of controls, and knowing how many conductors are in each conduit will be helpful as you determine the size of the conduit and the size of the wires required. So let's look at this one. We've got a starter off to the right, two separate push button stations, and a junction box in the middle. So again, we have three power conductors that are coming down from our panel. They will go through the junction box. I'm not going to sketch them in there. Maybe I will. And they will continue all the way over to the starter. So I have 1, 2, 3 of these conductors going off to the starter, and they would terminate to the line side of the starter. Then out of the starter, we would have to have three conductors go all the way back down to the motor. So let's sketch those in. 1, 2, and then finally 3. So in this top conduit, I have three conductors. In the bottom conduit, I have three conductors. And so far, I have 6 power conductors in this conduit. All right, well, let's take a look at the controls. Same setup where I have 2 normally closed push buttons. In this arrangement too, it does not matter which of the normally closed push buttons I terminate to first. So I'm going to do the logical sequence, and I'm going to connect to that one first, the closest one, why not? And then I'm going to connect those 2 push buttons together, the 2 normally closed. So the 2 normally closed terminate together. And then out of the other side of that normally closed, I have to connect to both of the start push buttons. So I'm going to connect these 2 first. So I'm going to come out and terminate. And then I'm going to connect this normally open to that normally open. So, same spot. There we go. Now, I've done this connection here. What else do I have? NEMA 2. Do I need to run a separate wire from both of these push buttons to NEMA 2? Of course not. Instead, what we do is we run one conductor from one of those push buttons down to NEMA 2. So I'm going to run it from this one. I'm going to go all the way back to NEMA 2. There we go. All right, so final items that we need to look at would be on the right-hand side of my two normally open push buttons. First, again, let's determine, does each one need to have a separate wire going back to NEMA 3? And the answer is no. Let's put them in parallel first. Let's connect this push button with that one, and then let's run them to NEMA 3 as a single conductor. So, first step, let's connect these together, both of the normally open push buttons. And that would be doing this, like that. And now let's connect these normally open push buttons back to NEMA 3. So it gets a little messy here, I suppose. We could do, I don't know, maybe I'll just do a moret here. I'll do a connection. Now I really have a choice, don't I? I mean, I could take the connection from this push button, or I could take it from this one. But if I took it from this connector over here, wouldn't that mean that I'd have 4 conductors in this conduit? When really I don't need 4 conductors. I could get away with 3 conductors as long as I run the conductor going back to NEMA 3 from the closest push button. So I'm just going to draw a moret. There we go. And I'm going to run my conductor all the way back to NEMA 3. So now what do we have? Well, we have a total of 3 conductors in this conduit, 3 conductors in this conduit, another 3 conductors in this conduit, which would mean the total for this conduit is 9 conductors. All right, well then let's take a look at probably the most common arrangement we have for motor controls. And I'm going to do it twice, at least the controls I'm going to do twice, just to show you the difference in the number of conductors we could get. So I'm not going to draw the power circuit. I'm only going to draw the control circuit for this particular arrangement. So let's take a look at where the first terminal will terminate to, or the first wire. NEMA 1 to the first push button station. This one, I'm going to choose to go to the closest push button first. Okay, now I have to go to the second normally closed push button. So that means that I have to go all the way back. I have to go through the starter to the other normally closed push button. Now what I have to do is I have to connect this normally closed to the normally open. Okay, well that's not too bad. So let's do normally closed to normally open. So normally closed, there we go. And we're going to go all the way over to the normally open. Good. Now I have to connect both those normally opens together, and I also have to hit NEMA 2. So this is what we can do. We can take this conductor here, go all the way back, and terminate to NEMA 2, which would be doing this. But then we can also do the same thing on this side. This terminal, NEMA 2, could we not just continue it on and terminate to this normally open push button? And the answer is yes, you could. So if you don't want to have 2 wires at this terminal, you could draw a little moret and then just have 1 wire going in. But really, how many conductors do I now have? 1, 2, 3, and 1, 2. All right, so let's look at the other side. Again, the other side, my normally open push button needs to get back to NEMA 3. So here is my normally open push button, the other side of it. Let's go all the way back to NEMA 3. And this time I'm going to do it a little bit different. I'm going to draw a little moret in there, and I'm going to show that we are also connecting this normally open push button to the second one. And I can do that went too far. There we go. So what do we end up with in this situation? I want you to focus on the number of conductors and the length of the conduit. In the first scenario, so example number 3, what we're doing, we have 4 conductors in the shortest conduit, and we have 3 conductors in the longest conduit. Let's take the exact same sequence or arrangement, and instead of going from NEMA 1 to the closest push button, let's take NEMA 1 and go to the furthest push button first. So here it is. Same arrangement as before. This time, the only difference, what we're going to do is we're going to take NEMA 1 and go to the furthest normally closed push button. So I'm going to go all the way down to this one first. I'm then going to connect both of the normally closed push buttons together. So it's going to get a bit mucky in here because of the number of conductors we have, but we can still do it. Good. I'm then going to take my normally closed and connect it to my normally open. Good. And I also have a second normally open push button, which I neglected to sketch in here. There we go. Good. So there's my other normally open push button. Where is that going to connect in? Well, remember, we need to get power somehow up to this one too. And we need to get down to NEMA 2. So let's take this, go over to NEMA 2, and then we'll Moret on. So we've done this. We'll Moret on, and we're going to go all the way up to the other normally open push button. So from here, we come out, and we go all the way down to the other normally open push button. I'm going to bust out of the conduit because I don't have enough room here, but we all understand. I probably would have run it in the conduit if I had the choice, right? Kind of hard to see here, but there it is. So at this point, now we have the final connection, which is this back to NEMA 3, all the way back. And then I'm going to do a little moret, and I'm going to go to this second normally open push button. And so again, what we're going to end up with, I'm going to run it out of the conduit just so I have space, is a situation, and I know it's kind of hard to see there, I'll scratch it in a little bit with some black marker, but what we have happening is more conductors now in the longer conduit, which is not what we would want. So right here, how many conductors do we have? 4 conductors in the longer conduit, whereas over here, we only have 3 conductors. So what is the lesson to learn from this? Well, this would be considered incorrect. Why is it incorrect? Not because it won't operate, it will certainly function totally fine. The reason it's incorrect is that it has been wired inefficiently by requiring us to put in far more wire than with the previous example. So this one is definitely wrong, and wrong because we wired NEMA 1 to furthest normally closed push button first. That's why we got this situation. And we got more conductors in that longer conduit length. If we were to go back to our third example, we would say that this arrangement, this is correct. They both function the same. However, this one is more efficient. And we wired NEMA 1 to the closest normally closed push button first. The least number of conductors is always the correct answer, bearing in mind that it obviously has to function, right? So, hope that helped you along in your wiring conversion for your motor control circuits.